Okay, let's get started here. We're going to be looking at the iterated integral of x plus y quantity squared, and we're going to be integrating from 0 to 1 dx and from 0 to 1 dy. The best way to think about these problems is by imagining a grouping symbol in the middle that traps the interior integral. So we can rewrite the problem like this. When we talk about iterated integrals, this is the formatting that we mean. We're going to integrate with respect to x first, and then integrate with respect to y. Integrating with respect to x, we can bring that interior integral over here to the side and ignore what's going on with y for a second. So copying it down, it's going to look like this. The best way to integrate this is to treat this as a u substitution problem. So we're going to set u equal to that interior portion, x plus y. Here we differentiate with respect to u, like normal, and on the right side we differentiate with respect to x. We can also modify the limits of integration, because when x is equal to 1, we can plug it into the formula for u and see that u must be equal to 1 plus y. Likewise, we plug in 0 for x and modify that limit of integration to get u equals y, because x is equal to 0. This allows us to rewrite this problem as the integral from y to 1 plus y, which looks a little weird, but that's okay. We're just going to substitute those in at the end here. And the interior part, x plus y, becomes u squared du. This we integrate like normal. We don't have anything special to do. So we increase the power by 1 and divide by the new power, which gives us 1/3 u cubed. And then we evaluate it from y to 1 plus y. Plugging things in, we're going to get 1/3 times the quantity 1 plus y cubed minus y cubed. This is our answer that we're going to substitute back into our expression here on the left-hand side. We have the integral from 0 to 1 of now 1/3 times the quantity 1 plus y cubed minus y cubed dy. This now is simply an integral with respect to y. It integrates very similarly. We can imagine it as a simple u substitution problem. I'm going to skip the details here because I think it's pretty easy to see. We can bring the 1/3 on the outside, and then integrating the inside term by term, we increase the power by 1, divide by the new power, increase the power by 1, and divide by the new power. And this is going to be evaluated from 0 to 1. And now it's just a matter of plugging in numbers. So we're going to get 1/3 times 1/4, which we have factored out. We're going to get 1 plus 1 to the 4th power minus 1 to the 4th in the first part here. And then in the second part, we subtract from that 0 plugged in. So we get 1 plus 0 to the 4th power minus 0 to the 4th power. And putting everything together, we get 1/12 times 16 minus 1 minus 1, which is 14/12 or 7/6. Not so bad. It's just a matter of treating the things that don't matter like constant values.